This is Mr. Martin. These are the worked out examples for the investigation 4.3. So in 4.3 so far we've talked about the triangle inequality conjecture and the side angle inequality conjecture. So these are a few examples that you have in your packet that I'm going to work out solutions for you. So for the first example, we want to determine whether it is possible to draw a triangle with the lengths of the sides given. If it is not possible, explain why. So we talked about the triangle inequality conjecture, where if we add up the lengths of the two smaller sides, in order for it to be a triangle, it's got to be larger than the third side. So what we want to do is we want to take a look at the two smaller sides, so that's the 4 and the 5, and we want to compare it, the sum of those, to the 8. So I can see that 4 plus 5, and we want to compare that to the 8, and we see that 9 is greater than 8. So since the sum of the two smaller sides is greater than the largest side, yes, this can form a triangle. All right, let's take a look at the next one. Again, we want to isolate the two smaller sides. So in this case, we have 4 and 7. And the larger side is going to be 12. So I want to compare the sum of the two smaller sides. So that's 4 and 7. And we want to compare that to 12. So we get 11 is less than 12. So we can see that the sum of these two sides is not bigger than the third side. So no, this cannot form a triangle since the sum of the smaller sides is not greater than the third side. Okay, so if I had a segment here that was 12 inches, and then I had one that was 4, if I put it over here, that would be 4, and if I put one over here, that would be 7, and we see that we would have this gap in here because 4 and 7 won't make up the side that's 12. Okay, as always, if you have questions, make sure you pause the video and write those down and ask me the next time you see me. All right, moving on to number 2. The length of two sides of a triangle are given. We want to find the possible range for the third side. So we've got a triangle, and we know that two of the sides are 12 and 9. So for the third side, it has to be smaller than 12 plus 9, which is 21. But the third side has to be larger than 12 minus 9, which is 3. Okay, so making sure that it's smaller than 21 and larger than 3 will make sure that we satisfy the triangle inequality theorem. So the third side, it has to be between 3 and 21. Okay, so the third side is greater than 3 but less than 21, and this is how I want you to write your answers as well. Okay, so if you want to go ahead and pause the video and try the next two examples, feel free. Otherwise, keep the video rolling, and I'm gonna keep going as well. So we've got the third side, it's going to be smaller than 4 plus 7, so that's 11. But it has to be larger than 7 minus 3, which is 4. So I know that my third side has to be between 4 and 11. All right, moving on. I know that it has to be smaller than 25 plus 20, which is 45, but it has to be larger than 25 minus 20, which is 5. So my third side has to be between 5 and 45. Okay, now it can't equal 5 or 45 because then the sum of the two smaller sides wouldn't be greater than the third side, but it can be between them. All right, moving on to example 3, we want to put the sides of each triangle in order from shortest to longest. So remember, our side angle inequality conjecture says that the longest side will be opposite the largest angle. So we've got two angles given, and we can find angle D. Angle D is going to be 180 minus 80 plus 69. So that's going to be 31. So this is 31. So we want to go from shortest to longest. So I want to look for the smallest angle, that's 31. So the side that's opposite it is going to be the smallest. So the smallest side is going to be EC. The next smallest angle is 69. So the side opposite that will be the next smallest. So that's DE. And then the third side opposite the 80 will be the longest. Again, if you want to try and figure these out on your own, feel free to pause the video and then restart it to check your work. So we need to find the third angle in this triangle. Again, I'm going to add these two together, subtract that from 180, and again, if I did my calculations correctly, that's going to be 65. So the smallest angle here is 35, so that's going to be the smallest side, SR. And then 65 is the next smallest angle, so ST has to be the next smallest side. And then 80 is the largest angle, so the longest side is going to be side TR. Okay, so for number 4, we want to order the angles, but this time from largest to smallest. So we're going to be looking for the longest side first and the shortest side last. So the longest side here is 17, so that means that the largest angle is going to be angle G. The next largest side is 12, so that means that angle E will be the next largest, and then the smallest angle will be angle F. And then for example B, again, largest to smallest, so the biggest side is 19, so angle V will be the largest angle. And then 18 is the next biggest side, so angle W. And then lastly, we have angle X. So that's from largest to smallest. So make sure you read the directions carefully so you know whether it's asking for largest to smallest or smallest to largest for your angles or your sides. All right, again, if you have any questions, make sure you write those down or you ask me, pause your video at any time, and we'll see you in the next video.